Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Fitri bin Rodi, MA 17224, and today I would like to present lab presentation group 4 for heat radiation, BMM 3531. So for introduction, radiation is one of the transfer modes from the study of heat transfer mechanism. It is different from the conduction and convection, in which it does not require the presence of a material medium to take place. Thermal radiation emitted as a result of energy conversion of molecules, atoms, and electrons. So all matter that whose temperature is above the absolute temperature will emit thermal radiation. So today the lab is for experiment based on the Stephen Boltzmann's law. Understanding is conducted for the radiation experiment. So the objective is to study the effects of distance of heat source and radiometer and the reading of the radiometer. Number two, to study the relationship of a aperture opening and the radiometer reading. That's all from me. Thank you very much.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Ghassan Sami Al-Usta, and today I will present about methodology for the experiment setup and equipment. As shown in this figure, we did two tests. So for test one, which showed that the intensity of the radiation varies as the fourth power, the source temperature as stated in Stephen Boltzmann's law. So first step is to connect one of the thermocouples of the target plates to the service unit and place the plates on the bench to record ambient temperature. Secondly, position the radiometer on the test track at 800 mm from the heat sources. And select the selector knob on heat transfer service unit to read the radiometer measurement. Set the heater temperature to 250 Celsius by heater controller. Okay, when T4 value has stabilized, move the radiometer to 300 millimeter from the heated plate. Next, move the radiometer to 800 millimeter from the heated plate again. Also repeat the above procedure with an increment of 15 Celsius, 200 Celsius and 400 Celsius. Lastly, calculate the relationship between the Stephen Boltzmann law and the corrected radiation reading given as a factor of F. This is for test 1. For test 2, which to demonstrate the exchange of radiation energy from the surface to another is dependent upon their instrument geometry. For the first thing is to install a pressure holder at 200 mm from the heated surface. Then install the radiometer on the track at 800 mm from the heated surface. Supply 400 Celsius to the heater monitor to T4 inductor reading on the heat transfer. When T4 value has stabilized, move the radiometer position to 100 millimeter from the aperture position. Next, install the aperture plate on the aperture holder and adjust the width to 5 millimeter and calculate the area factor. Lastly, plot area factor against aperture width graph. And that's for me, and my friend will continue with the result and calculation.
Hello, my name is Muhammad Mafi bin Salahuddin. My material ID MA180CS. So I will present about the result from our experiment radiation heat. So we made two tests. The test one to show the intensity of radiation varies of a fault power, the, the source of temperature as stated in the Stephen Boltzmann law. For the table 1, show the value for the heater temperature, distance, radiatometer reading, correction radiation reading, temperature 1, and temperature 4. Uh, so we need to find the radiometer reading, correction radiation reading, temperature 1 and temperature 4. Uh, Heater temperature is already given, which is 250 degree, 300 degree, 350 degree, and 400 degree. So the distance is a constant, which is 300 millimeter. So the next slide show how to calculate and how get the value from the radiometer reading, correct radiation reading. Uh, so we have different value for the heater temperature. So I took the first value first is 250 degree. Uh, uh, First, find the energy radiated by the black body QB equal stress. The constant value is a Stephen Boltzmann. The value is 5.67 multiply 10 power minus degree, multiply with the bracket T 4 minus T1. Reminded that the temperature must in the Kelvin. So the temperature T1 and T4 need to plus with the 273.15 Kelvin. So after we calculate, we get the answer 3839.63 watt per meter square. So R is a radiometer reading. From the QB divide with the stress Stephen Boltzmann, and we get the value 677.18 watt per meter square. So find the delta. We use the formula tan multiply power negative 150 per h. So our constant distance h is 300 millimeter. So we use it. Then we get the value is 0.1651. QR is the heat radiation from the radio radiometer reading, multiply with the sine square with a delta, and we get the value is 103.59 watt per meter square. Correction to find the correction factor C, formula C is equal QR divide with R, and we get the answer is 0.15. For the calculate the corrected reading, uh, RC equal to C multiply R. We get the value 102.0785 watt per meter square. So we calculate same way to the value heater temperature uh, to 300, 350, and 400 degree Celsius. So for test 2 is to demonstrate that the exchange of radiant energy from one surface to another is depend upon their interconnecting geometry. So the mm is increased by 5 5 to 10 to 50 to 20 to 25 to 20 to 20, 30 to 35 and 14. uh, so we get, so from the table 2, we get this plot graph. That's all from me. Thank you.
Assalamu alaikum, my name is Khalid Bahisami, my ID MA17189. I'll continue from here for discussion. For first question, what actually happened during heat radiation process? Change in temperature is molecules, atoms, and electrons generate heat radiation, which is radiated by the substance. The base at which heat radiated increases as the temperature rises. The motion of electrons, atoms, and molecules causes radiation to be continually emitted, absorbed, or transmitted throughout the volume of matter in all solids, liquid, and gases above absolute zero temperature. When it comes to opaque things, it's a surface phenomenon. Since radiation released by internal regions can't reach the surface, and radiation that touch the surface usually absorb within a few micron of the surface. For question 2, what is the most significant point that can be deduced from your relation between the Stephen law and the corrected radiation reading, RC? According to the Stephen law, the total blackbody emissive power EB is equal to the sum of the radiation emitted at all wavelengths. EB can only be calculated using R, which is the energy emitted by a unit area of blackbody surface for a radiometer calibrated to measure radiation. Because of their mathematical link in the Stephen law, when the corrected radiation reading R rises, so does the thermodynamic temperature. Discuss about the graph you have plotted. As you can see in this graph, the area factor with aperture opening. When the size of the aperture opening is increased, the area factor increases. The area factor is critical because the rate at which the heat flows from one radiation block surface to another is determined by how much each surface can see of the others.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Yunus Majid Jadi. My matrix is MA17246. Today I'm going to explain a little part from the discussion. There is a question been asked in the discussion, which is, what is the factor will affect the radiation process? So the first factor is the transmissivity, which is the percentage of the light that is transmitted and varies with the wavelength. There is incoming radiation that can be passed through the substance, the higher the transmissivity. The second factor, which is absorptivity, varies with the temperature of the incident radiation source. The greater the absorption, the lower the temperature. The third factor, which is emissivity, compares the radiation released to a certain surface to the radiation emitted by black body at the same temperature. The last factor, which is the reflectivity, is determined by the incident radiation direction or the incidence of the reflection. And now for the last part of our presentation, which is the conclusion. The objective of this experiment is achieved based on the result obtained from this experiment. It shows that the level of radiation increases when the temperature of the heater increases. The radiant heat energy has been analyzed theoretically, and it has emitted from a surface to the fourth power of its absolute temperature. This theory is caused by the dark colors of the black body that absorb more radiant energy. However, we are grateful that our objective is achieved in this experiment, and we have done successfully with the guidance of our lab instructor and cooperation for all team members. That's all from us, and thank you.